Thank you very much. Welcome on to this talk, which is charting the course, History and Evolution of Kubernetes Security. So we obviously already heard in the keynotes that it has been 10 years of Kubernetes. So what I wanted to do with this talk was take a bit of a look back at how Kubernetes was in the old days, and also how that has got better, and some places where maybe it hasn't got better, and we still need to think about this. And I'm also going to talk a little bit about some Kubernetes vulnerabilities over the years that I think are interesting and can teach us something about how Kubernetes works. So before I get started, the very quick about me, why am I doing this talk? I have been in security for a while. When Kubernetes first came out, I was a pen tester. I worked for a large pen testing company, and inevitably we started getting asked by customers, can you do security reviews and pen tests of our clusters? And a lot of what I wanted to talk about today was how we found clusters in those days. These days, I am a senior security advocate for Datadog. If you haven't heard of Datadog, we are a large observability and security company. In the community, I do a couple of things. I help co-author the CIS benchmarks for Docker and Kubernetes. If you've used like a cloud security posture management tool, of which there are lots, you've probably inadvertently encountered this, so I apologize for any problems those cause you. I also participate in Kubernetes SIG security. So if you're interested in Kubernetes security and you haven't, want to get more involved, please do come along. We've heard about the SIGs already a couple of times in the keynotes. We're a very friendly group, I hope, and we've got things we can talk about security. Lastly, I'm also very proud to be a member of the only unofficial Kubernetes SIG to have ever keynoted a KubeCon, which is SIG-Honk. And we actually have 2 of the 4 members of SIG-Honk in today, with Duffy obviously as being one of the other ones. And unfortunately, the other 2 members are in the States. So anyway, let's get on with the talk. I'm going to take you back now to 2016, the dim and distant past of Kubernetes. And we were getting customers asking us about Kubernetes and saying, hey, can you do security reviews? So as pen testers always do, we started investigating, digging around, looking at what can we find. And one of my colleagues sent me this. The repo is still up there. This is the Kubelet exploit from someone called Keras. And I read this repository. It's quite short, just a description of a feature. And they said to me, anyone who can get network access to the Kubelet service, which is the node API, which I'm sure you all know if you run Kubernetes, can automatically get command execution without authentication on every node in the cluster. And I said, remote command execution without authentication? I'm interested. That sounds like something I want to know about. So I dug into this, and I thought, is this really true? And I stood up a test cluster, which was a lot harder in those days because we didn't have kind. So I had to do it properly and in a difficult way. And it proved that this was true. And that's how I got started in Kubernetes security. Because in the early days of Kubernetes, up until I think 1.5, the Kubelet had no authentication. As in, there was no option you could turn on, it just didn't have it. So if you deployed Kubernetes in those days, if you're any of the early adopters, maybe you did, you had to do something very clever and start doing things like SSH tunneling to essentially allow the Kubelet to be secured. There was no security on it. And this was what got me interested in Kubernetes security. These days, that's obviously not a problem because most clusters have got that fixed. The other thing we used to run across a lot in the early days with the kubelet was the read-only kubelet. And the read-only kubelet, it was essentially give you read-only access. You could, without authentication, you could dump every pod config off every node, which as a pen tester, again, it wasn't the end of the world, but it was a really good starting point. It gave you something to really think about. These days, kubelet security is a lot better, right? If you try to do a kubelet and you get to the host path, you'll get 404. If you try to do anything sensible, you will get authentication required. The read-only port is largely gone. And when I was researching this talk, I was going to say the kubelet read-only is totally gone, because as far as I was concerned, it was. And then I realized that GKE clusters are only just deprecating it now in 2024. So if you're running GKE, this is still something you need to worry about. If you don't want anyone with network access to the kubelet to get read-only access to all of your configuration information, all your pod information, then you do still need to worry about this in GKE. They are deprecating it. To be fair to them, they've been trying to deprecate it for a while, and it is finally getting deprecated now. But it's an interesting point about Kubernetes security in general, is it's very hard to make sweeping statements. I can't say the kubelet read-only port's totally gone, because it turns out it's one distribution, as long as you know. But there's 120, I think, Kubernetes distributions. So it's quite tricky to always know exactly what you're going to go and say. So that was our first thing, and that got me interested, right? I'm interested now, I'm a pen tester, I can get remote command execution. What else did we come across when we started looking at people's clusters? Well, this was great. If anyone's been doing Kubernetes a while, you might remember this. There used to be a thing in the API server called the insecure port, literally called the insecure port, which gives you a clue about what it was. Basically, if you could get to the API server on port 8080 and this flag was set, you got cluster admin, just flat out. No authentication, no authorization, just there you go, that's you with cluster admin. This feature was deprecated in Kubernetes 1.10, but didn't actually get removed until 1.20. So it was still around in 1.20, which isn't that long ago. And I will say that in a lot of the early days, we compromised clusters with this. You know, you'd come on site, you'd do a port scan, you'd find that port, and once you knew about the flag, you just pointed kubectl at the port, and that's you, your cluster admin. My favorite one of this was there was a major cloud provider, and their early managed Kubernetes service, the first one they launched, actually put the insecure port on the container network. So anyone with a container could do this. And because it was a managed service, the customers couldn't turn it off. So it was, again, sometimes surprising. Defaults is a thing in Kubernetes. Don't always assume that every distribution you use will act the same as every other one, because sometimes you might find something, not that one anymore, that is now properly gone, 120, deleted from the server, can't be there anymore. But we got a lot of clusters that way, and it was definitely a thing. The other thing we ran across a lot in the early days, irrevocable credentials. This is I put this one up because it's my favorite Kubernetes issue. I know it's sad to say that, but it is genuinely my favorite KK issue, which is 18982. It's been open since 2015. And what it says is we want to have support for revoking client certificates issued in a Kubernetes cluster. It's still open, as you'll see, because that issue is still going. In the early days, when we rocked up to clusters, we'd say to people, can you give us a set of creds so we can review the configuration? And they would give us a client certificate file. And a lot of times, the client certificate file turned out to be the one that was issued when they'd start the cluster up, which was a member of a group called System Masters, which meant, if you know about System Masters, it gives you cluster admin and you can't revoke it. So they essentially gave us this thing that lasted a year or 2 years and couldn't be revoked and gave you cluster admin. We had to inform them of that at the end of the test and say, you have kind of left us with this backdoor, we will delete the file. And in the early days, we saw a lot of clusters that used client cert authentication with that downside. We also used to see, in the old days, well, up to about actually it's not that old, up to a 123.24, every service account in the cluster had a secret that was how you got access. Those secrets were not revocable and never expired. So the only way you could revoke them was deleting the service account, which was a tricky one if it was a system service account. So in the early days, you dumped the secrets out of a cluster and you said, well, listen, now anyone who can do that has got persistent access. So that's not great either. Not having long-lived irrevocable certs are generally a really bad idea, because the realistic fact is that they get leaked. People leave them in a Git repo, they copy-paste them somewhere, they put them in a support ticket. Something will happen that causes that to be leaked. And in the early days of Kubernetes, unfortunately, there was a lot of that. Things have got better. Theme of this talk. Things do get better in Kubernetes security. Now, if you're using things like managed Kubernetes, it's all authentication, or should be for your users via Cloud IAM. So you're not relying on Kubernetes to issue the credential, you're getting the credential from your cloud provider, and they can do revocation and everything like that. Service account tokens are now not persistent. We have the token request API. This was a great effort that SigAuth went through to essentially gradually, because it's quite difficult to do, because this is obviously, if you get this wrong, people's clusters break. They've gone from non-expiring secrets to expiring token requests. So this is now a lot better than it was. But there are still some things to know about, things that if you're running Kubernetes today to know about. The first one is client certificates haven't gone away. You can still issue client certificates if you want to, unless you're using EKS, where they've turned off that API. Every other cluster, you can issue a client certificate. It will last for years, and you can issue highly privileged ones if you've got enough rights. So you still need to know about that API and lock down access to it. And it's still possible to issue long-lived tokens using the token request API. Again, depends on the distribution. Anything from 1 day up to a year, depending on exactly how they configured it. But things are better. Kubernetes authentication is better. It's not quite the Wild West of how it used to be with system masters everywhere. So let's move on from authentication to authorization. RBAC didn't always exist. If you're relatively new to Kubernetes, you'll expect every cluster you ever had to have RBAC, right? That's how we control access to the cluster, how we authorize people's access. That wasn't always the case. In the very early days, we used to see that one quite a lot. Always allow. As a pen tester, this was a great authorization mode, because it said that once I've got credentials, I'm cluster admin, which is a good day. And we would get a lot of clusters that would have that configured on it. Even when RBAC first came in, people didn't adopt it immediately. So in some of the early reviews, you would essentially get your creds and automatically cluster admin. That should have gone now. Typically now you'll see RBAC. If you're using managed Kubernetes, you'll also have webhook authorization. that comes from the cloud provider. So you'll have one or more authorization methods, but you shouldn't see that. And I say that, but I do want to give another caveat, because this is a Kubernetes security talk, and I can't not give caveats. There's at least one distribution that still sets always allow as the default. And RBAC is an option that you have to know to add. This is a little bit tricky, because all of your manifests will still work. If you create cluster roles and role bindings, they'll all go into the API server, and they'll appear to have applied fine, just they won't actually do anything, because the RBAC authorizer isn't configured. So again, be a little bit careful. Don't assume that every distribution is going to enable RBAC. I kind of hope they would, but it's not true. At least one I know of. I'm sure there could be others, because I've not looked at all 120. We'll still have that. We'll have it always allow. So authorization better, but be careful. What else did we used to do? We used to use the most pointless Kubernetes pod ever. This is what I used to call it. It was based on a blog post by Ian Mile. He had a command called the most pointless Docker command ever. And this Docker command, essentially, you run a Docker command, and it drops you as a root user with full access to the host file system and all of the host resources. So it's a pointless Docker command. Like, why would you do that in Docker? So when we were doing pen tests, we had a thing called the most pointless Kubernetes pod. And it basically dropped you into root access with access to the full file system, access to all the host resources. And in the early days, you would do this all the time, because people didn't turn on any restrictions on what someone could do if they had create pod. So you'd go to the cluster, apply the manifest, and you root on the node. Then it's just a question of hunting round, trying to find credentials to escalate to cluster admin. And this actually, the fun thing about this is I used to have a manifest, and I had this lying around. And then what happened was it turned into a kubectl command. So kubectl debug node. I love kubectl debug node, because it means I don't have to carry my manifest with me anymore. And that does the exact same thing. Drops you in as a root user with access to the file system, which is great. Now, this obviously not great for security. Really, everyone who has create pod in a cluster should not have root access to nodes. And in the early days, we had pod security policy. So introduced in 1.3, deprecated in 1.21, removed in 1.25. This is kind of the reason why we used to get that to work in a lot of clusters, because pod security policies was a bit awkward. It wasn't the easiest thing to use, and it was never really that well loved. So it got removed in 1.25. And these days, we've got a lot of different ways of doing this, a lot of different options. We have got pod security admission, GA in 1.25. So if you have simple needs, right, you don't want everyone with create pod to get root. You don't have a lot of complexity in your clusters. Pod security admission is a good solution to that problem. It allows you to set a couple of different profile levels per namespace. So essentially, on a given namespace, you say, this is the profile I want to set. It's a good way of stopping the problem. If you've got all your clusters are nice and up to date, we can use validating admission policy now. GA in 1.30. This lets you set complex fine-grained policies using cell language, and essentially can stop things, privileged containers, you can stop access to host namespaces, all these things. This is built into Kubernetes, so you don't have to have any external software. So if that's something that works for you, it's a good way of doing it. And obviously, it's fair to say there's obviously a load of, and I can't list them all, it's down the bottom there, Kyverno, OPA, lots of other ways of doing this externally. So you shouldn't have that problem. But with that said, it's another important caveat. None of this is turned on by default. Right? If you get a Kubernetes distribution out of the box, you set up the cluster, anyone with create pod still gets root access to the underlying nodes, with I think the honorable exception of OpenShift, who I'm pretty sure the default restrictions don't allow that. But I'm not aware of any other distribution that's the case in. So you still have to be careful with Kubernetes. You don't want that to happen. You do need to implement one of these. But now there's lots of choices, lots of flexibility. You're not restricted. And it all works pretty well once you get it going. So that was a lot of how we used to break into clusters. This next one is not Kubernetes, but I could not do a talk about how pen testers used to compromise clusters without mentioning Helm. So in the old days, and we heard about Helm in the last talk, but that'll be Helm 3, I very much hope. In the old days, we used to have Helm 2. And Helm 2 had a component that ran inside the cluster called Tiller. And the way it worked was your Helm client would talk to the Tiller service, which would talk to the Kubernetes API server and would deploy your charts. But that ran inside the cluster. And one of the notable things about how Tiller worked was, by default, it didn't have any authentication. So anyone who could reach the Tiller service inside the cluster could get access to Tiller and could do whatever they want. Typically, that ended up being cluster admin. So all you had to do was get that. And what we would do is they would give us a compromised container, and we would just look in DNS for Tiller, which is a nice, easy way of doing it. You'd find Tiller using Service Discovery. You'd hit Tiller, and you'd get cluster admin. And we compromised a lot of clusters using that approach. When I was doing this talk, I thought this is a historical thing. This doesn't exist anymore, surely. No one's using Helm 2, right? There was a very interesting, and I thoroughly recommend reading it. There was a very interesting research done by Wiz and their research team. They were looking at an SAP AI service. It was a managed multi-tenant AI service. And they had a step through where they compromised the entire thing and got cluster admin. What was very interesting was the way they got cluster admin was, you guessed it, unauthenticated Tiller service. That was July 2024 that came out. So we'd love to hope that Tiller was completely gone, but I have a feeling that there's probably some environments where it lurks around. If you, for any reason, still need that, be aware they do provide authentication for that. It's just it's not on by default. So a lot of people don't configure it. But that one, yeah, was a lot of fun as well. So all of those were like configuration options, things that you could turn on or maybe couldn't turn on, depending on the version of Kubernetes you were using. But if we're going to talk about the security of the product over time, we need to talk CVEs. Kubernetes, this is a sort of very basic chart of all the CVEs from the kind of Kubernetes official CVE feed that have been issued over the years. And honestly, from my perspective, as somebody who's spent a lot of time in security, for a product with the complexity and reach of Kubernetes, it's a pretty good record. We haven't had huge numbers. 2020 had a bit of a spike, and we could speculate that that was because a lot of people were sitting at home because they weren't allowed to go out. I'm not sure if that's true or not, but I did notice it. I thought, I wonder if that's why it was. But honestly, it's not been that bad. And there have been quite a few of these where, you get a CVE, and, you have to go and patch the product, and then you apply the patch, and then that's fine, right? I don't need to worry about this anymore. And that is how a lot of CVEs go. But sometimes with CVEs, vulnerabilities in a product, understanding how they work can actually lead you to know something more about what the product does, how it works, the assumptions they've made when they've built it. So it's actually quite a good time sometimes reading the descriptions of how these things have been discovered. And what I wanted to do with the rest of this talk, see how much time I've got, was quickly talk about what I call the unpatchable 4. So there are 4 CVEs in Kubernetes that you cannot apply a patch for. If you're running a Kubernetes cluster, you have got the absolute latest version you possibly could have. You still have these 4 CVEs in your cluster because there are no patches. In every case, you have to apply some configuration, or you have to apply an architecture change to how you run your environment in order to address them. And so what I want to do with the rest of this talk is talk through them, because each one of them actually illustrates something I think interesting about Kubernetes. So we'll start with CVE 2020-8554. The way this one works is if you have a multi-tenant cluster, right? So you've got 2 sets of people in your cluster who don't trust each other, but they're both allowed to create service objects. If I am a bad person, I can create a cluster IP service object with external IPs configured in it. And in doing so, I can hijack any traffic for those IP addresses. So if I know someone over here is trying to communicate with an external system, and I know the IP address of the system they're trying to communicate with, I can say, hey, my service is totally that IP address. So can you please send the traffic to me instead? And it will, quite happily. Because when you think about how Kubernetes does services, they are IP tables rules. And an IP tables rule can redirect traffic. That's one of the things you can do with IP tables. So you basically can hijack the traffic and send it to wherever you want. This is actually quite an interesting one because it works in every single cluster unless, and I'll mention this because I know there's isovalent people in the room, if you're using Cilium without kubeproxy, this doesn't work because it relies on kubeproxy and how kubeproxy uses IP tables. But this still works today. So the question is, do I care, right? Because the thing about CVEs is you might not care. And the answer is, if you're running multi-tenant Kubernetes, yes, you care. You do not want this. This is bad. If you're running clusters where you've got internal teams, you probably don't unless you're expecting one of your teams to try and hijack traffic from one of the other teams, which doesn't seem like a major scenario. But if you're doing multi-tenancy, you absolutely do care. There is an admission controller that you can enable. I've never seen it enabled by default. And of course, the challenge being with it, if you're using managed Kubernetes, you don't have rights to change them. So that's a slight problem. Or you could use something like Kyverno or Op or one of the validating admission controllers. You could block this. Essentially stop people creating external IPs on cluster IP services if you want to stop this happening. But that's what you need to do. There is no patch. I've got a demo for this one. It basically works in any Kubernetes you want to try it in. I said, apart from with the exception of Cilium. So that's that one. It's kind of fun. Next one is also really fun. I apologize for the complicated thing, but let me explain how this works. Basically, this is exploiting a thing called server-side request forgery. And server-side request forgery is a vulnerability where you persuade some system to make requests on your behalf. And if that system can reach other services that you can't reach directly, you can get access to them essentially around the site. So the way this one works is there's a thing called validation and admission webhook object in Kubernetes. If you've got rights to create these, then a request will be made to whatever IP address is specified in that object every time you create a pod. So an attacker who's got enough rights creates an object, then they try to create a pod, and it says, I'll go and make a request to you. And that could be something on a network that you can't access. So that's the idea. You're trying to get access to systems. So that works quite well, but you don't get to see the response in that attack. Right? I can't see what that external host that I'm trying to compromise actually comes back with. So then we can explore another Kubernetes feature. And this is kind of exploring how Kubernetes works. Has anyone heard of the debug pp-roff endpoint in Kubernetes API? Okay, nobody. Awesome. Kubernetes enables profiling by default on the API server every single time. There is an endpoint that will expose the detailed profiling information on every API server. It is enabled by default in Kubernetes. You have to explicitly disable it. Within that endpoint, there is a thing that lets you change the log level of the API server remotely. So you can crack up the changing log levels. You can crack the log level up to debug on any API server if you've got rights to that endpoint. If you crack the log level up to debug, you can see the responses to your attack. So you can see the information that comes back from whatever host you're trying to compromise. So the way a CVE works is first you crack up the log level, create a validated admission webhook, and then try and create a pod, which then causes the request. And then you read the logs from the API server. So that tells us, when I was reading this, I was like, oh, cool, I didn't even know this pp-roff thing is. And now I'm dug into that. What's interesting is that I've been looking at some of the managed providers and saying, do they know to disable this endpoint? And the answer is that all the big ones do. But I've tested two mid-tier managed security Kubernetes services that don't disable that endpoint. So technically, I could go and log up their debug levels on their shared control planes up to debug and let their disks fill up. Of course, I didn't do that. I reported to them and said, hey, you probably didn't want this setting. But worth checking, if you're using managed Kubernetes and one of the big providers, whether that's disabled or not. And it's really easy to check. You basically just do a kubectl proxy and then check the endpoint. But that one's fun, right? Because it told us more about how Kubernetes works. So the next one, 25.8662. Kubernetes has, this is another SSRF bug, right? So that's 2 in a row for SSRF, unpatchable. Kubernetes generically has a bit of a challenge around server-side request forgery because the API server is a proxy, right? The API server is an HTTP proxy by design. That is what it does. So if it is a concern to you to let the API server make requests on your behalf, then you probably have some things to do. One of the things the API server does, though, is it tries to stop you making proxy requests to sensitive IPs. So, for example, if I say I want to make a request to localhost, and I want to make the API server make a request to localhost on my behalf. Now, lots of people bind things to localhost that are maybe not as secure as they could be. For example, the insecure API port. It used to be bound to localhost a lot. So if I can fool the API server into making a request on my behalf to localhost, that's not good from a security standpoint. And as a result, the API server has, in its source code, hard-coded list of addresses that it will not proxy to. Right? So it won't proxy to localhost. It won't proxy to the metadata address. However, the way this is coded, there is a block of code in the API server that says this is the check for whether you're allowed to make this request. And then there's another block of code that makes the request. They're two separate blocks of code. So if I could say make a request to a DNS name, and I control the DNS server, I can say make a request to that for me, and it says, oh, it's on 12, 12, 12, 12, whatever. And then on the second block of code asks the DNS to check again, and it says, oh yeah, actually that's localhost. Then I get access to localhost. It's what's called a talk to, time of check to time of use vulnerability. And this exists in Kubernetes. It is not patchable. It does work. I've actually tested this out in some managed Kubernetes providers, and you can totally exploit this. It is, however, possible to mitigate it. So the question is, first, the question we always have with these CVEs is, do I care? Well, it's a relatively privileged operation to make this work. So you probably only care if you've got a separate set of people who have access to privilege in the API from who have access to control plane network. The obvious example is managed Kubernetes providers, right? If I'm a managed Kubernetes provider, I do not want my customers making requests from my API servers inside my internal control plane network, right? Because that's mine, it's not the customer's. So if you're a managed Kubernetes provider, you do care about this. And how do you fix it? Well, the way you fix it is, has anyone ever heard of a service called connectivity with a K? I know Duffy has, a couple of people have. So connectivity, but not many hands. Connectivity, if you actually have managed Kubernetes, try looking in your pods in kubesystem, and you might find some pods called connectivity. It's a service that can be deployed in scenarios like this, that essentially sends any traffic that comes from the node plane, from users, back down the tunnel. It basically says, I'm not going to let you make requests that go out into my control plane network. I'm going to send all of this back down the tunnel into the network that you own to stop literally exactly this problem. So if you're doing managed Kubernetes, do be aware of this one. And do think connectivity is where I would recommend looking. That's the best way to fix this problem. That's definitely how the big managed Kubernetes providers fix this problem. So that was fun as well. Last one. This is another one which basically is a multi-tenant issue. So multi-tenancy in Kubernetes is hard to do. And we all know multi-tenancy is a bit of a tricky one. The way this one works is if I have, again, I've got two different groups of namespaces owned by different sets of people. And say I own this namespace here. I want to be able to get to some pods in this namespace, but I'm not allowed. Someone put network policies in place, and they said, oh, you're not allowed to get to that namespace. It's blocked. But we have a shared load balancer. So the load balancer serves both namespaces. If I can create an endpoint object that says, oh, actually, my service that I own, it's not in the IP address you thought it was. It's actually over here, please. Well, the shared load balancer can make requests down there. So it says, oh, OK, I'll just send your traffic down there, and you can make requests over the shared load balancer to the namespace you're not meant to have access to. And again, this is a feature of how Kubernetes works. But it's important to know if you are running multi-tenant Kubernetes. Of course, if you're running, again, you trust your users, you don't have a problem, you probably don't need to worry about this one. But if you don't, then it is something to consider is, how are you going to mitigate that? And probably restricting create endpoint and being a little bit careful who you allow to do that is one way of doing it, or logging for it, or using admission control again. But this is another one which kind of illustrates some of the challenges. And what was interesting to me when I was doing the talk and when I went through all of this is that all of these are networking issues, right? Every single one. All four of these, these are the only four I'm aware of that are unpatchable Kubernetes CVEs. And it speaks to me about the fact that Kubernetes networking is a bit of a complex topic. There's a lot of abstractions in there. There's lots of things that have been done to make it work. And you do need to consider those when you're thinking about how you do your network security, because things like the Kubernetes API server being a legitimate proxy server, like it's a full-on proxy server, you can send headers, you can do all sorts of fun stuff. But that's by design. You do need to know about that, because if you don't want people sending requests from your API server IP address, or you're making decisions on, I'm going to trust this because it's the API server, rather where I wouldn't trust a client, yeah, that's definitely something to explore as to whether it works for you. So, to bring a conclusion, hopefully to say Kubernetes security has got a lot better over the years. I think that is an inarguable point. If I look back at the early days when I started doing Kubernetes pen tests, when we would literally rock up to site, find one of those first three things, and we'd have cluster admin by lunchtime, in most cases. That's no longer the case, right? It's not, well, I very much hope that none of the ones I described are still there and anyone's working clusters. I would hope that's no longer the case. People have done a lot of work. Kubernetes project itself is far more securable than it used to be. But that's not to say out of the box you have no work to do if you want to create a secure Kubernetes environment. You do. There's some of these things that aren't on by default. There's some of these things that vary by Kubernetes distribution. So there's things to think about. There's definitely some sharp corners to be aware of. And also some complexities in how you use it. What is your threat model? Do I care about multi-tenancy? Do I care about I'm trying to do a managed Kubernetes provider. I'm doing hard multi-tenancy, one of the really tricky ones. And then there's even more things to think about, like the unpatchable 4. So hopefully that was useful and interesting. I think I've got a little bit of time for questions. But if people want to ask questions later on, I am on all various socials, and links are there.